Have you ever actually stopped to think about the physical reality of the internet? Welcome to this explainer, where we are going to dive into exactly how the world's biggest digital platforms manage to scale globally without completely crashing. It's so easy to just think of the cloud as this magical thing floating up in the sky, but today we're going to bring that concept right back down to earth. Okay, let's kick things off with a really practical question. How exactly does streaming video work flawlessly across the entire globe? Or think about this. How do millions of people use highly demanding AI applications at the exact same time without completely breaking the internet? Or even simpler, how do websites stay online when a server inevitably goes down? Well, the secret lies in the physical architecture of cloud infrastructure, specifically the massive global infrastructure built by Amazon Web Services, or AWS. To understand this macro to micro architecture, here's our roadmap. We'll start with the cloud behind the scenes, then figure out what an AWS region is, zoom inside an availability zone, and finally, look at speeding things up with the edge.
All right, Section 1, the cloud behind the scenes. Let's look at this on a literal planetary scale.
See, when we talk about AWS Global Infrastructure, we aren't talking about something invisible. It is an actual, tangible, worldwide network. We're talking highly secure data centers, massive storage and security systems, endless rows of servers, and ultra-fast private fiber networks crisscrossing the globe. Whenever you open a mobile app, fire up a streaming service, or use enterprise cloud software, there is a very high chance this exact physical infrastructure is working tirelessly behind the scenes to give you a seamless experience. To really give you a sense of this massive footprint, get this. AWS currently spans 123 availability zones within 39 geographic regions worldwide. That is absolutely huge, and they are expanding rapidly, with more infrastructure already planned for places like Saudi Arabia and Chile. This expansive footprint is designed specifically to support any size of organization, from a tiny startup launching today to a massive government entity, letting them run workloads literally anywhere in the world. Moving right along to Section 2. What is an AWS region? Let's explore these geographic clusters. So the absolutely crucial thing to grasp here is that a region is a physical, geographic area right on the map. Think of places like US East in Northern Virginia, or Europe in Frankfurt, or Asia Pacific out in Singapore. AWS actually maintains these geographic regions across all 6 permanently inhabited continents. It's basically the highest level grouping of their physical infrastructure. But what's really interesting here is how AWS separates itself from other cloud providers. Some providers define a region as literally just a single data center, not AWS. An AWS region contains a minimum of 3 completely isolated availability zones. Plus, every single region is fully isolated from all the other regions. This intentional isolation is a total game changer because it gives you the power to build incredibly secure and stable disaster recovery systems. Let's look at why choosing your region actually matters with a real-world example. Say you're building a website primarily for users in Sri Lanka. You definitely want to choose the Singapore or Mumbai region to host your application. Why? Because that physical geographic proximity means drastically faster response times. The data literally has less physical distance to travel, and less distance translates directly to lower latency and a way better user experience. Now, large enterprises won't just stop at one region. They will actually deploy it across multiple regions at the same time. For example, a company might run their main app in Singapore, back up all their data in Tokyo, and utilize another region entirely in Europe. If some massive, unprecedented event takes an entire continent's network offline, a backup in another region just steps in and keeps the business running seamlessly. This is exactly what we call high availability. All right, Section 3, inside an availability zone. We are zooming in to the city-level clusters now. As we mentioned, inside every single AWS region, you are going to find multiple availability zones, or AZs. For example, in the Singapore region, you have AP Southeast 1A, 1B, and 1C. But what are they? Well, they are physically separate data centers, and they're connected to each other by high-bandwidth, ultra-low latency fiber networks. And here's the kicker. An availability zone isn't just a separate server room inside the same building. No way. Each AZ operates entirely on its own. We're talking independent power infrastructure, independent cooling systems, independent networking, and they are physically separated by up to 100 kilometers. That specific distance is incredibly deliberate. It's far enough apart to prevent correlated failures, but close enough to allow for synchronous data replication with practically zero delay. The ultimate goal of all this physical separation is to prevent what's called a shared fate scenario. Basically, a severe lightning strike, a fire, or an earthquake shouldn't wipe out your entire application. Common points of failure simply aren't shared across different availability zones.
So let's map out exactly how this fault tolerance works for your apps. Imagine your e-commerce site has web server 1 running in AZA and web server 2 running over in AZB. If AZA loses power unexpectedly, AWS automatically, without you doing a thing, redirects all your user traffic to AZB. Your users can just keep shopping, and they'll likely never even realize there was a massive hiccup in the background. That is the true superpower of this architecture.
Finally, Section 4, Speeding Up with Edge. Let's look at the user's absolute nearest access point.
So while regions and AZs are these massive data center clusters, edge locations are smaller infrastructure sites that sit way outside those traditional regions. Powered by services like Amazon CloudFront, Route 53, AWS WAF, and AWS Shield, these dispersed points of presence exist for one main reason: to securely cache and deliver content as close to the actual user as humanly possible.
Think about it like this. Imagine your main application is hosted all the way back in that Singapore region, but a user tries to log in from Brazil. Without the edge, that request has to physically travel all the way across the globe and back, creating a massive, super annoying delay. But with an edge location, the content is served almost instantly from a local cached copy right there in South America.
This highly intelligent network mapping and routing mechanism provides single-digit millisecond latency. Single digits. By keeping the data geographically near the people who are actually requesting it, you drastically lower the delay, you optimize your costs, and you hugely improve the overall performance for anyone, anywhere in the world. And if you want to see the real-world impact of migrating to this kind of purpose-built architecture, just look at Discover Financial Services. By migrating their card settlement environment over to AWS, they utilized this scalable infrastructure to increase their transaction processing speed by a massive 66%. That drastically reduced the time it takes to adopt pricing changes, all while enhancing their security. So from planetary cables to city-level clusters to hyperlocal edge caches, the physical reality of the cloud is basically an engineering marvel designed so you never even notice it's there. So with the world's most resilient infrastructure humming quietly in the background for you, if server crashes and network latency are no longer your problem, what impossible idea are you going to build next? Thanks for joining this explainer, and keep building.